This experiment investigates the electrolysis of aqueous solutions using inert carbon electrodes to identify the products formed and any pH changes around the electrodes. The apparatus is a beaker containing the test solution with two graphite rods connected to a direct current supply, and optional gas collection tubes, a splint, blue and red litmus, and a fume hood for safety. During electrolysis, positively charged cations move to the negative cathode and gain electrons, while negatively charged anions move to the positive anode and lose electrons, and electrons flow through the external circuit from the anode to the cathode. In the diagrams, the cathode is colored blue and the anode red. And because the solvent is water, the mixture also contains hydrogen ions and hydroxide ions that can be discharged. A simple rule for the cathode in aqueous solutions is that metals less reactive than hydrogen, such as copper, silver, and gold, are deposited, otherwise hydrogen gas is released from water. A simple rule for the anode in aqueous solutions is that halide ions, such as chloride, bromide, and iodide, give the halogen when present at sufficient concentration. Otherwise, oxygen gas is formed from hydroxide ions in water. For copper 2 chloride solution with carbon electrodes, copper ions are reduced at the cathode to copper metal, and chloride ions are oxidized at the anode to chlorine gas, with the half equations Cu2 plus 2E negative gives Cu, and 2Cl negative gives Cl2 plus 2E negative. You will see a pink-brown coating of copper on the cathode, bubbles of greenish chlorine at the anode, a bleach effect on damp blue litmus held above the anode, and the solution around the anode gradually turns acidic. For aqueous sodium chloride, sodium metal is not produced because water is present, so hydrogen gas is released at the cathode and chlorine gas at the anode, with the half equations 2H2O plus 2E negative gives H2 plus 2OH negative, and 2Cl negative gives Cl2 plus 2E negative. Gas tests confirm the products. Because hydrogen makes a squeaky pop with the lighted splint, oxygen relights a glowing splint when it is formed in other electrolysis, and chlorine bleaches damp litmus and must be handled in a fume hood. The pH near the cathode becomes alkaline as hydroxide ions are formed, and the pH near the anode becomes acidic as hydrogen ions or chlorine form, and this can be shown by universal indicator or blue and red litmus. Record the observations, write the half equations for each electrode, state the overall ionic equation, and explain the choices made by the selection rules before switching off the power, rinsing the electrodes, and disposing of solutions safely.